Hello and welcome to Solva, a ZK solvency verification layer for Bitcoin custodians built on Starknet. The problem: when you deposit a Bitcoin with a custodian, you have no way to verify they actually hold the reserves they claim. Solva fixes that with zero knowledge proofs. Here, math replaces trust by hashing the UTXO into a Peterson-Merkle tree, and only the root is revealed to the public. So let's get started with proving our solvency. We'll just connect to the Bravos wallet and log in, and here we can see that the wallet is connected. So let's start with the proof tab. Here, what we're going to prove is just click on load demo addresses. So these are some addresses that I have already fetched from the Bitcoin mainnet. So right now, we're scanning the Bitcoin blockchain. Every UTXO is a confirmed Bitcoin output. All right, here we have. Now let's just click on build commitment and resolve proof. So here you can watch the terminal for the running pipeline. First, we build a Pedersen Merkle tree on BN254. Each leaf is a hash of the address and its balance. This isn't a simple single leaf Merkle tree. Our V2 circuit reconstructs the entire tree inside of the CK proof. All 16 leaf slots are verified in circuit and the aggregate balance is computed with zero external trust. So there it is, an 8.6 kilobyte of proof on BN254. Three public inputs go on chain: the Merkle root, the total liabilities, and the number of verified addresses. Everything else, the actual addresses, balances, UTXO data, stays private. Right, it is verified locally and ready to submit. So let's just submit on chain. The wallet is connected, so we're just submitting this proof to the solvency registry contract on the Starknet Sepolia blockchain. So the contract calls our Garaga generated verifier. That's an on-chain ZK verifier that Solva has deployed. Right. So the transaction has been processed by the Starknet sequencer. Once accepted, the registry stores the verification result with a solvency layer or a solvency tier and a 24-hour expiry. Right. It is now verified on chain. Any protocol on Starknet can now integrate with this. So let's just talk about what happened here. So we can go on to the transaction that was created here. The transaction that has been signed here, and it has now been verified in the L2, and in some minutes it will be accepted on L1 as well. Right. So after now, as I said, any protocol on Starknet can use this. So let's just go on to we'll go on to look at the integration layer on how it works. All right. So in the in Cairo, you can import iSolvency registry that we have on our GitHub and call the is solvent or get solvency info and gate your lending, minting, or any operation on verified reserves. right? So this is the solvency tier system that translates reserve ratios into risk parameters. Tier A, 150% reserves or more, gets 80% LTV. Tier C at 100% gets only 40%. No proof, no borrowing. All right. So here are the contract addresses. Now let's go to the dashboard. The dashboard shows a live solvency status for any issuer pulled directly from the Starknet registry via RPC. Proof, age, tier, multi-root, all on-chain, all verifiable. So Solva brings a trustless solvency verification to BTCFi. Real Bitcoin UTXOs, ZK proofs with full tree reconstructions, on-chain verification on Starknet, and a plug-and-play contract interface system for any protocol to use. No trust required, just math.